For plants to grow successfully, they need to be able to make the use of nitrogen in the air. Nitrogen is important to agriculture because it helps make chlorophyll for plants, which is used for photosynthesis. However, atmospheric nitrogen, or N2, is unable to be used by most plants. Luckily, there are bacteria in the soil that are able to transform N2 into more usable forms through a process called fixation. In order for the nitrogen to transform, its strong bonds need to be broken. Some ways that this can happen on a small level are by lightning and forest fires. Then, free nitrogen atoms can bond with oxygen, which builds more chemically reactive forms. However, most of the fixation that occurs happens through bacteria. Bacteria, for example, rhizobium, that inhabit the roots of legumes, convert atmospheric oxygen, N2, into ammonia, NH4+. The bacteria digest organic material and release NH4+ into the soil so that it can be used by plants to make amino acids. Nitrifying bacteria first oxidize NH4+ into nitrite, NO2, and then transform that further into nitrate, NO3, in a process called nitrification. Nitrification is a biological process and proceeds rapidly in warm, moist, well-aerated soil. Bacteria such as Nitrosomonas, Nitrococcus, and Nitrobacter use an enzyme called denitrogenase to be able to do this. After nitrification, the nitrogen then goes through denitrification. Oxidized forms of nitrogen such as nitrate, NO3, and nitrite, NO2, are converted to dinitrogen, N2, and nitrous oxide gas, NO2. This is done by denitrifying bacteria in an anaerobic process. Often this process occurs in wet soils where the water makes it difficult for microorganisms to get oxygen. Under these conditions, the denitrifying bacteria will process nitrate to gain oxygen, leaving free nitrogen gas as a byproduct. Once converted to dinitrogen, nitrogen is unlikely to be reconverted to a biologically available form because it's a gas and is rapidly lost to the atmosphere. Denitrification is the only nitrogen transformation that removes nitrogen from ecosystems, essentially irreversibly, and it roughly balances the amount of nitrogen fixed by the nitrogen fixers described above.